Hello everyone, my name is S Maheshwara and I'm an educator at an academy. And you can follow me by downloading the Academy learning app where you can find rest of my courses. And today we'll be solving a problem which will be based on the adiabatic process. Also, you can rate this, you can review, and you can also recommend this to your friends. Also, you can share this video. Also, you can follow us on our YouTube channel where you can find lots of amazing videos and you can increase your knowledge. So I'm looking forward to teach you guys. Have a good day, guys.
Hello guys and welcome back, and today we'll be discussing the lesson 5 of the topic of the compressible flow, and in this one we'll be solving a problem which is based upon the adiabatic process. And once again, my name is S Maheshwara and it may be mechanical, and this is my short summary. So to begin with, we'll start with the first question, and the first question, it goes like this. A gas is flowing through a horizontal pipe of area of cross section 50 cm square and a temperature of 15 degrees Celsius. At another section, the area is 20 cm square and the pressure at the section 1 and the section 2 is equal to 40 and 30. So these are the two gauge pressures and they are in the form of the Newton per centimeter square. If the mass rate of the flow of gas through the pipe is equal to 0.5 kg per second, then find the velocities of the gas at these sections, assuming an isothermal change, and take the value of R to be equal to 300 and the atmospheric pressure to be equal to 15. So in this question, we have to find the velocities at the section 1 and the section 2 of the pipe. So first of all, we will list all the data which is given in this question. So first of all, so at the section 1, he has given us the area which is equal to 50 cm square. So we will convert this into the form of the meter square by multiplying it by 10 to the power of minus 4. And the value of the P, which is the total pressure, will be equal to the sum of the gauge pressure plus that of the atmospheric pressure. So 40 plus 15, we'll get the value as 55. And we will write this in the form of the Newton per meter square. So we will multiply this by 10 to the power of 4. And similarly, at the section 2, the area is given as 20 centimeter square. And that is equal to this. And the value of P2, which is the total pressure, will be equal to the gauge pressure plus the atmospheric pressure, which is equal to 30 plus 15. So we get 45. Also, the temperature at the section 1 is given as 15 degrees Celsius. So T1 will be equal to 15 plus 273, which is equal to 288, because we will write the value of the temperature in the form of the Kelvin value. Also in this question, the value of the gas constant, which is R, is given as 300 and the mass flow rate is given as 0.5. So in this, we have to find what is the value of V1 and V2. So to find that, we'll be using the mass flow rate equation where so in this, the mass flow rate will be equal to rho into A into V. So in this question, we don't know the value of rho1, but it can be easily calculated by using this relationship, where the value of the rho1 will be equal to the P1 divided by R into T1. So in this question, we know the value of P1 is given, and we also know the value of R, which is 300, and we know the value of T1. So we will substitute over here and we get this as the value of the rho1. So we know the mass flow rate to be equal to 6.25. Or you can say we got the value of the density to be equal to 6.25. And since we have found the value of the density, we can substitute over here. And since we know the value of the mass flow rate, which is given as 0.5, and we also know the area. So after we substitute these two values, we can easily find the value of the velocity at the section 1, which is equal to 16. Now since this is an isothermal process, the temperature will remain constant throughout. So therefore, the temperature at the section 2 will also be equal to 288. So also in this, we'll be using the same the mass flow rate formula. So in this also, we will find the value of rho2. So the value of the density at that section will be equal to this particular relationship. So the value of rho2 will be equal to the P2 divided by R into T2. So in this, we know the value of the P2 and we also know the value of R and T2. So after we substitute all the respective values, we get the value of rho2 to be equal to 5.202. And since we know the value of the rho2, we will substitute it in the mass flow rate equation. So in the mass flow rate, this equation, we know the value of the mass and we have found the value of the density, and we also know the value of the area. So therefore, the value of V2 will be equal to 0.5 divided by 5.208 and that divided by 10 to the power of the minus 4 and 20. So after we solve this, we get the value of V2 to be equal to 40 meters per second. So in this question, we have found both the respective velocities. And now we will look into the second question. In the second question, it goes like this. A gas with a velocity of 400 meters per second is flowing through a horizontal pipe at a section. The pressure in that section is equal to 8 into 10 to the power of 4 and the temperature is 50 degrees. The section where the dia of the pipe changes, the pressure is equal to 9.6 into 10 to the power of 4. Find the velocity of the gas at this section if the flow is adiabatic in nature, and take the value of R to be equal to 290 and K to be equal to 1.4. So in this we have to find the velocity at the section 2, which is V2. So in this, first of all, we list all the data which is given in this question. So in this question, for the section 1, the value of the V1 is given as 400 and the value of rho 1, which is the pressure at this section, is given as 8 into 10 to the power of 4. Also the value of T1 is given as 50 degrees. So we will convert this into the form of the Kelvin by adding 273 to it. So we get this as the temperature at that section. Also at the section 2, the value of the pressure is given as 9.6 into 10 to the power of 4. So we will write it down, and the value of R, which is the gas constant, is given as 290 and the value of K is given as 1.4. So since this is an adiabatic flow, we will be using this as the Bernoulli's equation, which we had derived in the previous lesson. So this is the relationship of the Bernoulli's equation. So in this, what we'll do is that we will bring this value over here and then we'll be shifting this value over here. So after we shift, we can take the value of the K divided by the K minus 1 as common, and we'll be getting this as the equation. So in this, what we'll do is that we will substitute the value of K as 1.4, which was given in the question, and the value of the P1 and P2 is also given. So we will substitute them over here, and in this, what we'll do is that we will cancel the value of this G, this G, this G, this G. So we'll be getting this as the equation. Also guys, in this, you know what, this G and these two G's, they will get cancelled, but in this, mistakenly I have written it, so just ignore these two G's. So over here you will be having the V2 square divided by 2 and the minus of the V1 square divided by 2, and this is the equation. So in this question, we don't know the value of the rho 1 and we don't know the value of rho 2. And since this is an adiabatic flow, we have this as the relation of the density with respect to the pressure. So in this question, we already know the value of the P1 and P2. So what we'll do is that we will bring this value of rho 1 over here. So we'll be getting this as the equation. So whole to the power of the 1 by K, then this will become equal to the rho 1 divided by rho 2, and that value will be equal to P1 divided by P2. So we get this as the value of the rho 1 divided by rho 2. So what we'll do is that in this particular part, we will replace it by this value. So after we replace this, we get this as the equation. So in this, what we'll do is that this is in the form of the 1 by of this value. So if we get, or you can say if we bring the value of the P2 over here and this P1 over here, we'll be getting this as the equation. And now what we'll do is that we will simplify these two. So this P2 will become equal to the P to the power of the K minus 1, and this base will become equal to the P1 to the power of K minus 1. So we'll be getting this as the equation. And over here, and now finally what we'll do is that we will substitute all the respective values. So in this question, we know the value of the P2 and P1, and we also know the value of K. So after we replace them, we'll be getting this as the equation. So after we simplify this part, we get that to be equal to the negative of the 0.187 into P1 divided by rho 1, and that is equal to the V2 square divided by 2 and the minus of the V1 square divided by 2. So in this question, we knew the value of V1, which is equal to 400, as you can see over here. So we replace the value, and after that what we have done is that we wrote down the equation. So we know the general equation that the P1 divided by rho 1 will be equal to R into T1. So in this question, we know the value of R and we also know the value of T. So what we'll do is that we will do a direct substitution. In this case, we will write these two values. So after we do this, we get this as the value of the R into T1. So we will replace this value over here. So after we replace this, we get this as the complete equation. So in this, if we bring like this value over here, and then if we calculate the value of V2, we get the value of V2 to be equal to 250 meters per second. So we have solved this question. So we will, just quickly go through this question. So in this question, we had to use the adiabatic process. So we wrote down the equation for this. So in this, we got the value of this V1 over here, and we got the value of this pressure over here. So we get this as the equation. And after we substitute all the respective values, we will be getting this as the equation. And in this 2 is not there, it'll get or you can say this G is not there because it'll get cancelled over here. I have mistakenly written this, so just ignore this part. So over here you'll be having the V2 square divided by 2 and the minus of the V1 square divided by 2. So over here we see that over here there is the rho 1 divided by rho 2. So what we'll do is that we know the general relation for an adiabatic flow that the P1 divided by the rho 1 to the power of k will be equal to P2 divided by the rho to the power of k. So in this question, we have to find the value of the rho 1 divided by rho 2 so that we can substitute them. So what we have done is that we got this value over here, and then we'll be getting this as the relation. So from this we have found the value of the rho 1 divided by the rho 2, and then we substituted this value over here, or you can say in the main equation. So after we substitute, we get this as the complete equation. So after we simplify this, we'll be getting this as the relationship, and after this we will substitute the value of the P2 and P1. And after we simplify this, we'll be getting this as the equation, and in this we will write the form of the P1 divided by rho 1 in the form of RT, because the P1 divided by rho 1 is equal to R into T1. So the value of R is equal to 290 and the value of T1 is equal to 323. So after we substitute this value here, we can easily calculate the value of V2. So we get the value of V2 to be equal to 250. So we have solved this question. So guys, if you had any sort of doubt in this, you can feel free to ask me. You can rate, review, and you can recommend this to your friends, and you can also follow me. So in the end, I'd like to wish you luck and the to have a very productive day. Thank you.